Today, you will be happy, maybe, to know that we have a plethora of word problems. And these first two come from a set called Using Graphs to Solve Problems. And it should be quite educational. For those of you who know how to use your graphing calculator, it will enable you to do the problems better. And if not, at least you can see how a graph can help. Okay, so problem number 1 in your homework. This is the first set, Using Graphs to Solve Problems. Yardbird Landscaping has 46 meters of fencing with which to enclose a rectangular garden. And there it is. There's your rectangular garden. It's a rectangle. If the garden is X meters long, express the garden's area as a function of length. Okay, now, as a function of length, we're letting the length, which is the longest side, be X meters. And whenever we say let something be a function of X, we're saying the function of X equals something with X's in it over here. Now, since it's area we're talking about, we're going to call it A of X. And what that means is that we need to have A of X equals something with X's in it, and that something has to express what area equals. And of course, the area of a rectangle is length times width. Okay, so since X is our length, we could say X times width, but we need also to have width expressed in terms of X. So we're going to do that because we were given fencing, and fencing and perimeter are the same thing. The formula for perimeter is 2 times the length plus 2 times the width. Now, we know that the perimeter, the fencing, is 46 meters long. And the length is being called X. Why? Because in the instructions they said so. What I need to do here is I need to solve for W. Okay? And that will be in terms of X. So that means I isolate 2W. And I'm going to subtract 2X from both sides of the equation. And that will give me 2X minus 2X is 0. So I will have 46 minus 2X over on the left-hand side and 2W on the right-hand side. Now to solve for W, I divide by 2 and I divide by 2. The 2's cancel, leaving me with W. But now, that looks really weird to put in like this. oops, 2x rather, because we have now solved in terms of x. So while technically, yeah, you really need to reduce this fraction. And luckily, 2 will go into 46 and it will go into 2. So you can do this. You can take out 2 as a common factor up here. So I'm just going to extend this over here. I wonder if I should. No, I'm going to come up here. 46 minus 2w over 2 is going to be 2 times 23 minus w over 2. Now our 2's can cancel, leaving us with 23. Oh, this is x. Okay. All right, that was x. This is x. There. Okay, so the 2's canceled, leaving me with 23 minus x. Now this is a much simpler problem now. We're going to have a of x equals x times 23 minus x, which will be 23x minus x squared. Yes, that's true. So a of x for these particular numbers is going to equal 23x minus x squared. Now this is a function of area written in terms of x. But notice we had to use 2 formulas to do this. We had to use area equals length times width, and we had to use perimeter equals 2L plus 2W. We used this to solve for W since they had already named L length as X. And that permitted us, when we solved for W, to really be solving for X. And then it was just very convenient that 2 would go into 46. Okay, so we were able to pull out a common factor, which simplified the whole process tremendously, changed us from being stuck with a fraction here, which nobody wants to have to deal with, to 23 minus x. We now have length times width, so there you go. That's all they wanted. We didn't have to do anything with it. We just needed the practice of doing this because we're going to do it later. Immediately later. Okay. Any questions? Okay. Now we're going to go really do this and really use this. I wrote the questions down over here. Okay, you've got a daycare center. I think we've probably done this before. If not, we're doing it now. Every class does it, every college algebra class. A daycare center has 28 feet of dividers with which to enclose a rectangular play space in a corner of a large room. The sides against the wall require no No dividers, right? That makes sense. This is a wall. It's stationary. Ah, so here's where the dividers are going to go, right here. And the kids can play in here. Oh, let's put a dolly. A very Raggedy Ann. Okay, so suppose the play space is x feet long. So here again, we're letting x be the length. Well, this is a rectangle, so it has length and it has width. We don't know what those are. Okay, so I'm using dividers over here, and I really should have made it a different color. I'm not going to go to a lot of trouble to do that, but I might as well make a dashed line here. These are the dividers. Okay. Now, the length plus the width is going to equal the 28 feet. So all 28 feet of dividers are going to be used. All right, now length is going to be x. We have to figure out again what the width is in terms of x, or it'll make no sense. So we know that 28 is going to equal 1L plus 1W in this case, because we're not enclosing this part. So 28 is going to equal the length plus the width. Now solve for width. We subtract x from both sides. X minus x is 0. So we'll have W equals 28 minus x. All right, so our width is going to be 28 minus x. And now we're ready to start answering the questions. Now I knew to do this because I had already read the first question. So you probably wouldn't do it until you had read the first question. And that is just like this problem up here. Express the area of the play space as a function of x. Well, since we're old hands at that, we can do this now. It's going to be length times width. Area equals length times width. Okay, so if we want to call this A of x, which is what I believe they call it in this problem as well, we're going to have x times 28 minus x. And this is going to be our function, and actually this part of the problem, part A, has 4 choices you can choose from. But A of x is what the area is referred to as. Now the second question is a question that you don't normally stop to think of outside a math class. But domain is really whatever you're allowed to let x equal. So what can we let x equal so that this problem makes sense, so that we have some kind of play area for the kids? Well, the way you do it is this. You take a of x equals x times 28 minus x. Now, this is the length, and this is the width. If the length were 0, then all 28 feet of the dividers would be smashed up against that wall. And if 28 minus x, the width, were 0, then all 28 feet of the dividers would be smashed against this wall. No kids would fit, no toys would fit, because it would be flush. So let's go back here and say, okay, what makes this problem not make any sense at all? It would be if x were 0, or if 28 minus x were 0. Neither one of them can equal 0, because you absolutely won't have any kind of play space if that's true. Well, if 28 minus x equals 0, we need to solve for x to find out what x should be. So 28 equals x. Now, those, though, are the two numbers that would make this problem not make sense. If x is 28, then the width is going to be 28 minus 28, which is 0, which doesn't make sense. So the domain of a of x is going to be values of x that are strictly between 28 and 0. Because if x equals 0, then the length is 0. Crazy. And if x equals 28, then the width is 0. Then again, you've got the dividers leaning against the wall, but not any play space. So x needs to be between 0 and 28. And that's the reason it needs to be between 0 and 28, but not equal to 0 and not equal to 28. And I believe in the problem, you see this in set builder notation, which is x bar, x between 0 and 28, and then a brace on the end. Okay, I keep hearing somebody, and is somebody trying to say something? Okay. Well, now, the next thing you're asked is you're given 4 graphs, and you're asked which is the graph of this problem. And this is 28 out here. And this is 0 out here. And I think, well, they're different shapes. And this ends up being the answer, and I want to explain why. Here's x, this is the x-axis, so these are the values of x between 0 and 28. The y-axis is the area axis. If x is this much, then that's how much overall area you're going to have for the play space. If x equals this much, this is the area you're going to have for the play space. It'll be whatever that is. Okay, and if this is X, this will be whatever the area is, and so on. If this is X, then it looks like that's a little above that line. And then if this is X, it looks like that will be the area, and that looks like it's the very highest area. So if X is this much, then the area will be a maximum over here. But for this problem, this is the only graph that makes sense. When X is 0, when the length is 0, the area is 0. And when the width is 28, then the width is 28 minus 20. That is when X is 28. You've got 28 minus 28 here, which is 0, so the width would be 0. So the area would be 0 here as well, and larger in between. Yes, is somebody talking? I keep hearing someone's microphone. Just a little bit, like you're trying to say something, but it's not coming out. Like static, kind of. Okay. Well then, here's what they're asking. What are the dimensions of the play space? What are the dimensions of that and that will give us a maximum area, overall area? Well, we learned last time how to find maximums and minimums, which actually are pronounced maxima for plural, minima for plural. And here we're going to do that. We've got A of X, the area, equals X times 28 minus X. And if I distribute the X, we'll get 28X minus X squared. And then if I turn this around the right way, we'll have A of X equals negative X squared plus 28X, because it's positive, plus 28X. And there is no constant at the end, so there's kind of an understood 0 right there. Now, there's a 1, an invisible 1 in front of the X squared, so we have our A number equaling negative 1, and our B number equaling positive 28. And since the maximum area occurs at the vertex, we can find out what the X value is when the area is at its maximum by using the formula H equals negative B over 2A. Okay, that'll be negative 28 over 2 times negative 1, which will be negative 28 over negative 2, which is positive 14. So this is 14 feet. And then we have to remind ourselves, what does X mean? X is the length. X is the length. So the length, this means that feet. This means if the length is 14 feet, I put it right here. And now I have to find the width. The width is 28 minus x. That'd be 28 minus 14, which is also 14 feet. The width does not appear on the graph at all. You have to calculate the width from having found the length. And now this is a very interesting finding that you're always going to find is true. If you want to maximize the area of a rectangle, that area is going to be a square. So instead of looking like this, our area is going to look like that's as close to equal sides as I can get. 14 by 14 feet. And that's how you did this problem. Could we have done it without the graph? Yes. Yes. By using what we did last week, yes. But, oh, and that's all they ask. They don't ask for what is the maximum area, but we could find that, couldn't we? We could just say, okay, well, the area then, if we're dealing with 14 times 14, the area would be 14 times 14. Which is 196. 196 square feet. But they don't ask that. But you could find it very, very easily. So let's look at what we did with this problem. The first thing you did is you expressed the area in terms of x as a function of x. And so that meant you had to find out what the width is. And what made this problem tricky is normally you would say perimeter equals twice the length plus twice the width. But not in this problem, because you're not measuring the sides against the wall. You're measuring using 28 feet of dividers, which are over here on this side. So here you've got, okay, this half of the perimeter is going to be x by 28 minus x. And then you found the domain, which is totally new. If you were a builder, you actually use domain all the time. What am I allowed to let x equal? What am I allowed to let this length be? Okay, which is the same thing as saying, well, what would make this make sense? What would make this not a play space? Well, if either side were 0. So that's how you find the domain. Then you look at the graph. And actually, I think there's probably some way you can tell this is 14, but using what we learned last week, you don't need it because you can find that out just by using h. Oh, and by the way, if you were to take 14 and put it back in here, you would come out with k equals 196. because that's what this vertex is. It's the x coordinate, which is the length, and then the area you get if you put 14 into this function, a of x equals x times 28 minus x. So this is yet a new aspect to the vertex. Whenever you've got a quadratic function, which of course is what this is, and you see it once you multiply it out, highest power 2 quadratic function, it will only have this shape or that shape. And when the x squared is negative, when the quadratic term is negative, you have a cupped down parabola, which is what we have here, with the maximum at the top, which kind of makes sense. Any more discussion about this? Okay. Similar problem, but this time we're dealing with volume, so we're going to be in 3 dimensions. You have a 27 centimeter by 27 centimeter piece of cardboard. So 27 by 27. Let's even mark that. And we'll just say 27 for all us Americans who grew up with inches and feet. You got this slab of cardboard, and it's obviously a square, right? And you're going to cut squares of equal length out of each corner and fold up the cardboard so that you have a box pictured over here. And the X length right here, when it gets folded up, is going to be the height of the box. So that the base of the box, this was 27, this total length here, but then X was cut off, you know, it's folded up, so it's now X centimeters shorter, and then this side was folded up, so it's another X centimeters shorter, so that this side and this side are going to be 27 minus 2x, the base of the box, after the sides are folded up. And the same thing over here. Since this length is 27 feet, but this side was folded up, so it's x centimeters shorter, and then this side was folded up, so it's x centimeters shorter. This is going to be 27 minus 2x, and this is going to be 27 minus 2x. So that's what the length and width of the box are, 27 minus 2x. And I don't really know how to write it here, so I'm just going to say 27 minus 2x. On a tablet, it's really hard to turn the page around and write that way. So now, the area of the base of the box would be 27 minus 2x times 27 minus 2x, length times width. But the volume has another measurement in it, and that is the height. So the volume of a box is length times width times height. So that's going to be 27 minus 2x times 27 minus 2x times x. And that is the volume of the box being expressed in terms of x, because the length is x, the width is x. Well, that is, the length is in terms of x, the width is in terms of x, and the height is in terms of x. So all you've got over here is x's, and that means in terms of x. Now, doggone. We've got to find the domain of this. Now we've got three sides that cannot equal 0, or it won't make sense, right? If x is 0, that means you've never bothered to cut out the squares that you cut out. You never did it if x is 0, which would mean that you've still got a flat piece of cardboard. You have not got a box. So if we let each of these guys be 0 and solve, this is what we get. We get, and I don't want this to get cut off at the end, so I'm going to write it down here. For the domain, x cannot be 0. And 27 minus 2x cannot be 0. Okay, so that also is 27 minus 2x. So let's see what we get. We've got x cannot be 0, and I'm going to solve for x here by adding 2x to both sides of this equation, so that the 2x is over here on the left, 0 out. I'll have 27 equals 2, well, doesn't equal 2x, works the same way. Doesn't equal and equals, they work the same way. Divide by 2, divide by 2. And you get x cannot equal 13.5 or 13.5. And it says type your answer in interval notation, so that's what I'm going to do. X can be any number. If I were writing this in Set Builder, then what I would say is, okay, I've got X, and it can't be 0, and it can't be 13.5. But it can run anywhere in between. I mean, otherwise it's a word problem, the story problem. The story won't make sense. I mean, what if X were bigger than 13.5? Then what would I have? This side would be, say X were 14. Then I would have this side right there, or this side, being 27 minus 2 times 14. That would be 27 minus 28. That would be -1. -1 centimeter, -1 inch, -1 foot. Is that even possible? No, it's not. So that's why we have to go with these measurements. Now, my math lab would mark that wrong, even though it's right, because it wants the answer in interval notation. Okay, so X cannot equal 0. X cannot equal 13.5. But X can equal everything between 0 and between 13.5. Well, between 0 and 13.5. So this is our domain right here. What that means, if we translate it, to this graph, this is the domain of the function. If you were to graph this function in your graphing calculator, you would see that the red line actually keeps going to the left forever and to the right forever. It doesn't flatten out, it just keeps going down. In fact, I misspoke, it probably goes back up, probably. But our domain cuts it off for us so that the problem has meaning. And the reason this goes to 14 instead of 13.5 is that you want to be able to actually, if you were graphing this on your graphing calculator, you would want to actually be able to see these 2 points. So actually, this should have gone over to like -0.5, just so you can see the 0 and see the 13.5. But we're only allowed to use this much of it for the problem to make sense. Now, use the graph of the function shown below. Well, here it's over here, yeah. Determine the dimensions that yield the maximum volume. Okay, luckily we're saved by a graph. They tell us what the vertex is, which is kind of cheating, nice cheating. There's the vertex. The y coordinate is what the area is, the maximum area, the highest area. And that's 14.5. The x coordinate at 14.5 is 4.5. Now, what x means in our problem is it's the length of this little x square that we cut out of the cardboard. So now we know, once it gets folded up, that x is 4.5 centimeters high. Okay, now all I have to do to figure out these sides is take 4.5 and put it in for x. That's a point. Okay, that'll be 27 minus 9. 27 minus 9 is 18 centimeters. So the length and width of the box, because it's a square, the length and width of the box is going to be 18 centimeters. So we come down here, and there are answer boxes here in my math lab. You're going to have the width, the height being 4.5. The width being 18 centimeters. And the length being 18 centimeters. And that is how you do this problem. So you have to know that volume is length times width times height. And then you have to have a good imaginer, but luckily they give you a drawing here. You're going to fold up the sides after you cut out the equal length and width squares from each corner. You get x high, 27 minus 2x by 27 minus 2x. Length times width times height is the formula for the volume of a box. Now, to find the domain, you ask yourself, okay, if each of these is 0, does that make sense? And no, you wouldn't have a box, you'd still have the slab. So that's how you are able to figure out your domain. You let each of these guys equal 0. Since these give you the same, you go with 13.5. Then you look over at the graph, and this one tells you what the x coordinate is and what the y coordinate is, or HK. This is HK. H is always the x coordinate of the maximum of whatever you're dealing with, or the minimum, and K is the actual amount. And all you have are 4 problems on this particular homework. So there you go. It's always good to draw pictures. These aren't given on the problem, these little guys right here. I inserted these with my trusty PDF editor. But you could have done it with Microsoft Word or Microsoft something, or just with your hand. It's always good to draw pictures so you can see what you're dealing with. And now we have 2 problems. See, I'm not weighing you down with a lot of problems. That the button that says similar problem is there for you to keep clicking. You know, if you want practice doing the same kind of problem over and over, it's ideal. And then in question helps, you have help me solve this. You have show me an example. You often have videos. You always have the textbook. And you always have Ask My Instructor, which sends a message to me. You've got a lot of help. And you've got Multimedia Library over in the menu of Canvas. No, you don't. It's in the menu of my math lab. Okay, well, something you're going to be seeing more of. Probably. The Pythagorean theorem. Woo! When you've got a right triangle. The relationship between the length of the sides. Okay. Now it doesn't talk about area at all. It just talks about the relationship among, I should say, because there are 3. The relationship among the lengths of the lengths, plural, of the sides. So this is the famous a squared plus b squared equals c squared. And here we have the diagonal of a television set. The diagonal of a TV set is 26 inches long. The length is 14 inches more than the height. And here's the height. Find the dimensions of the TV set. That is, find the length and find the height. And we can do this because we know all about the Pythagorean theorem. I'm going to let the vertical side equal A, the horizontal side equal B, and the slanted side equal C. So we're going to have A squared plus B squared equals C squared, H squared plus H plus 14 squared equals 26 squared. So you can see that you're going to need your calculator, right? What are you going to do? So H squared plus H plus 14 times H plus 14 equals, whoop, here comes the calculator. Got 22 days left for a freebie. Still haven't totally decided whether to purchase it or not. Okay, so 14 times 14, I'm going to do that. I know we did it before, but still. All right, 196. 14 squared is 196, and 26 squared is 676. Meanwhile, H squared plus H squared plus 14H plus 14H plus 14 squared is going to be 196. Don't know why I don't memorize that. Oh, well, what was I going to erase? Oh, this thing. Okay, so we're going to have 2h squared plus 14 plus 14 is 28. We have 14 h's plus 14 h's. That's 28 h's plus 196 equals 676. And so this is a quadratic equation. I have to pull everything over to one side, set it equal to 0. So minus 676 minus 676. We'll have 2h squared plus 28h minus, because the larger number is minus, 6 minus 6 is, well, let's just do it on the calculator. Why take a chance? All right. Negative 676 plus 196. Negative 480 or minus 480 equals 0. And you have a GCF here. Always try to factor out your GCFs. Your life will be so much easier. 2 goes into 2, 2 goes into 28, 2 goes into 480. So this will be 2 times h squared plus 14h minus 240 equals 0. And then only because this is an equation, you can divide both sides by 2. An equation has an equal sign. It has stuff on the left and stuff on the right. Okay, so h squared plus 14h minus 240 equals 0 divided by 2, which is 0. And now, miracle of miracles, since there is a 1 in front of the h squared, I can use the easier form of grouping. I don't have to go through the AC method. It's enough just to factor negative 240 into 2 numbers that multiply to negative 240 and add to positive 14. And luckily, this is almost easy enough. Well, it is easy enough to do in your head this time. It's usually not. Because I know that negative 240 will equal 24 times negative 10, among other numbers. But these are the magic numbers because 24 plus negative 10 is positive 14. This is just 24 minus 10. I mean, this is great. So I make 2 sets of parentheses. Don't forget to set them equal to 0. I have positive 24 and negative 10. I take my h squared, I put an h here and an h here. I think of that as splitting h squared. And then I take positive 24 and negative 10 I turn into a minus 10. And now I set each factor equal to 0. Yes.
Where are you getting the h squared?
From back up here. A squared plus b squared equals c squared. Since I am letting h be a in the a position, it's h squared, and then I've got h plus 14 squared. So h times h is h squared, and I get 2h squared. And then I work with it from there until I get down to here.
Okay.
Okay, great. Any more questions? It's a good thing to, yes, it's good to ask questions, yes.
Where we have the negative 10, can you explain that part again?
Sure. I could have factored negative 24 the way I often do into all of its factors. But I know that 24 minus 10, that came first. 24 minus 10 is 14. And 24 times 10 is 240. So I knew that there'd be some combination there. Now, this is not positive 240, of course, it's negative 240.
Right.
And that means that negative 240 is going to equal a positive number times a negative number.
Right.
So since I know there's a relationship between 24 and 10 and 14, I kind of explored that with, all right, what about negative 24 times 10 or 24 times negative 10? And then if I add these together, I get negative 14. Well, I need a positive 14, but it definitely means I'm on the right track. 24 plus negative 10 equals positive 14. So bingo, that was it. Sometimes when you have a hunch, if you try that first, you don't have to go through all the factoring.
Okay. Okay. Thank you.
You're welcome. Any more? Okay, then we're on to just about the end here. I'm going to solve for h. Minus 24, minus 24. Minus 24 is 0. That will leave me h on the left, and 0 minus 24 is negative 24 on the right. And then over here, I've got h minus 10 equals 0, so I add 10 to both sides. Negative 10 plus 10 is 0, leaving me with an h on the left. 0 plus 10 is 10. Now that's great. We're dealing with the lengths of the side of a television set. There's no possibility we could have negative 24 inches. There's no such thing. So I mark out negative 24. We're going to go with the positive h equals 10. So the height of this television set is going to be 10 inches. And the length of the television set is going to be 10, because h is 10, plus 14 equals 24 inches, but positive, not negative. So the dimensions, finding the dimensions of the TV set, means finding the length and finding the height. And we did. The height is 10 inches and the length is 24 inches.
So you're always just going to drop the negative if it's a negative?
No, it doesn't always work.
Okay.
So you always want to check it, just to make sure. Because sometimes you can get fooled. I've had it happen to me. More questions before we take a break. All right, let's be back at 9:15.
Miss Barbara, I have a question, but not about it's about the exam.
Yes.
So if I already did it on Wednesday, do I have to take it again tomorrow or not?
No, you never have to take it again.
Oh, okay.
If you're happy with your grade, you don't have to.
Oh,
It's
okay.
all up to you. The second time is always voluntary.
Okay, thank you.
You're welcome. All right, it's 9:15. let us move along with the open box. This one's different, and it's the same. An open box is made from a 30 centimeter by 60 centimeter piece of tin is made from An open box is made from a 30 centimeter by 60 centimeter piece of tin by cutting a square from each corner and folding up the edges. The area of the resulting base is 1,624 squared centimeters. What is the length of the sides of the square? Okay, what they mean is this square. Let me make it a little bigger so it's easier for me to write small. Okay, what is the length of the side of that square? Because squares, of course, are the same length on each side. So our goal here is to find out what X is. And we're told that the base of the box has an area of 1,624 squared centimeters. That's the base of the box after the sides are folded up. So we're going to use what you learned last time, or one of the previous times earlier today. Since this piece of tin, now it's tin, since this piece of tin was 60 centimeters, but then it lost X centimeters when this side got folded up, and it lost X centimeters when this side got folded up. This is now going to be 60 minus 2X. In fact, I should write that inside the base of the box right there. 60 minus 2X and 60 minus 2X. And the 2X again comes from two sides being folded up, and so the 60 gets shortened by 2X. Same thing happens to 30 centimeters. When you fold up the other two sides, it becomes 30 minus 2X. And 30 minus 2X. And if we come over here, everything can be much neater. Where this is 60 minus 2X. And this is 30 minus 2X. This, yeah. Okay, meanwhile, of course, it's X units high, X centimeters high, but we're not being asked about the volume. We're just being asked about the area of the base, which we're told is 1,624 squared centimeters. Well, gosh, length times width is height. Length times width is area. Area equals length times width. So 1624 equals, let me make sure it's really 1624, okay, is going to equal the length 60 minus 2X times the width, 30 minus 2x. And so this whole thing is more of a multiplication problem. All right, 60 times 30 is 0,018. 60 times 30 is 1800. 60 times minus 2x is minus 120x. Negative 2x times 30 is negative 60x. And negative 2x minus, negative 2x times negative 2x is positive 4x squared. Oh, very cool. Okay, so we're going to have 1624 equals 4x squared minus 180x. Yes, plus 1800. And then we're going to subtract 1624 from both sides. Bring down the 4x squared and the minus 180x. And now 10, 9, 17, that's 6, 7, 1, and the bigger number here is positive, so this will be positive. Somebody should double check that on their calculator, just to make sure. All right, now, I do know that 2 will go into all three of these numbers. Let's see if 4 will go into them. Okay, 4 of course will go into 4. 180 divided by 4 is 45. So let's gamble, but not for money. I'll be very disappointed if it doesn't go into 176, but I believe it does. Yes. Okay, happy camper. We have ourselves a GCF.
Miss Barbara,
Yes.
why are when we're writing down the steps, why are we writing it 4 times 45x? Shouldn't we just put a 45x? Or
I found out that 180, that 4 goes into 180 45 times. I'm just trying to find a GCF, that's all. And I'm guessing that it's 4. Now, I could have been wrong.
okay, so you when you
Yeah, I
write
was
it out
just
like
guessing and I was right. I mean, ideally, it would be really nice to get rid of that 4 because then my factoring would be so much easier. I don't like the AC method any more than anybody else.
Gotcha. Okay.
Okay, good. So 4x squared. Here's our GCF. So minus 45x plus 44. And what happened there, what I usually do with GCFs is I circle them in red, usually. So I pulled out the 4 to the front, right there, which is where we usually pull out greatest common factors. Usually, we put them in front. And then, I mean, I have to keep saying this, only because it's an equation can I make the 4 disappear. Okay, so 0 divided by 4 is 0. These 4's cancel, and I'm left with x squared minus 45x plus 44. And the fact that there's an invisible 1 in front of the x squared means that I do not have to use the AC method to solve this. I can use factoring easily. Okay, all I have to do is this if, and that is always true, if I can factor positive 44 into 2 numbers that add up to negative 45, and again, I can, because positive 44 equals 1 times 44, but as luck would have it, it also equals negative 1 times negative 44, and I don't have to break this down anymore because I know that negative 1 plus negative 44 is negative 45, so bingo! My numbers are going to be minus 1, the negative 1 gets turned into a minus 1, the negative 44 gets turned into a minus 44, and so here I have 2 factors that I can set equal to 0 and solve for x and get 2 possible answers for the size of the x. So now, x minus 1 equals, I don't do that. X minus 1 equals 0, and x minus 4 d4 equals 0. Add 1, x equals 1, and add 44, x equals 44. I have 2 positive answers. Could they both be right? And the answer is no, because if x were to equal 44 centimeters, that's even greater than this whole side. How could that happen? It couldn't. In the context of this problem, 44 makes no sense at all. So 1 is going to be our answer. X, the length of the side of the little bitty square cut out of the corners, is going to be 1 centimeter. Suppose I should make that black. 1 centimeter. So look at what we did. This is neater over here. We multiplied length times width of the base because we're talking about the base. The area of the base is 1624 squared in a square squared centimeters. They're not asking for the volume this time. They're just asking for the length of the sides given the area of the base of the box after the sides have been folded up. So there you go, step by step. Discussion about this.
Miss Barbara,
Yeah.
at the top is where I lost you. So where we have the 1624 equals 1800 minus 120x minus 60x plus 4x squared. Where did the 4x squared come from?
Negative 2x times negative 2x.
Okay.
Good question. Yeah, you've got, let me put my little arrows here. You've got 60 multiplying 30 and negative 2x. And then you've got this negative 2x multiplying 30 and multiplying that negative 2x.
Okay.
We are now going to, last week we analyzed some quadratic functions, talking about the vertex and how the vertex gives you how if you have the graph of a quadratic function shaped like that, then the vertex is at the bottom, so it's a minimum, gives you a minimum. And if you have the graph of a quadratic function shaped like this, the vertex is at the top. That is really bad. The vertex is at the top, and it gives you a maximum. We're going to be doing some applications of those kinds of problems. Okay, namely, and you see this a lot, with thrown objects. Was someone going to say something? Okay. If a baseball is projected upward from the ground, from ground level, with an initial velocity of 160 feet per second, then its height is a function of time and is given by this. Okay, before we start, there's a general formula. H of t. You are not expected to memorize this, but I just want to help you make sense of these problems. Okay, this is the acceleration of gravity, which is always down, so I don't even have to put a negative in front of it because that is a negative number. The acceleration of gravity is a mathematical indication of the power of gravity pulling something down. It's often a set number. V sub 0 is also called V naught. This little zero under here, oops, this little zero under here and under here means initial or in the beginning. In math, initial means beginning. All right, so V naught is the initial velocity. The initial speed of the ball. The speed in the very beginning, as soon as the pitcher releases the ball, what is that velocity? And H naught means height in the beginning. Initial height. You're going to see some problems that start 180 feet above the ground because somebody's standing on a building and they shoot off a toy rocket. So these equations are always in this form. Now, the reason that this equation looks like this is that the ball was released from ground level, which is 0. Okay, so we don't bother to write +0. But that's the reason it looks like this. Now, this is the acceleration of gravity in feet per second. Actually, if you want to be picky, it's A/2. If you've had physics, you already know that. But okay, this is how we normally, in everyday America, would use the acceleration of gravity. -9.8 is the acceleration of gravity in meters per second. Both of those, this is feet per second, both of those are on planet Earth. They're averages on planet Earth. They change a little bit depending on how high above sea level you are and what the, remember there's a bunch of lava, a liquid core inside the Earth. And so there's a lot of shifting that goes on. And so actually our acceleration of gravity is always changing, but not enough so that you can really measure it. So these are averages. Now that's just a little background information to say that anytime you have to answer, even in advanced physics, a question about a ball being released from ground level and going upward at 160, what is it, feet per second? Yeah, feet per second. That's what it's released at, the speed it's released at. And you know from experience in life, it's going to go slower and slower and slower and slower the higher it goes. And then it's going to start coming down and going faster, 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 faster again. So here's what we're being asked. What is the maximum height reached by the ball? And I added, and how long does it take for the ball to reach its maximum height? Because you're going to automatically find out both answers anyway. How? You're going to be finding the vertex, the maximum height of a quadratic, which is what this is. T squared is acting like x squared, and S is the old letter that used to be used for height before any of us were born. And it still is a lot of the time. We are going to find, all we have to do is find the vertex to find the maximum. I mean, this has a negative in front of the t squared, so it is a cupped down parabola. So, here we go. The vertex is a maximum point. Okay, it's HK. Where this is the X coordinate and this is the Y coordinate, but sometimes X is called T. So this is going to be the time it takes, H is, to get to the maximum height. This is the time, the thing that's acting like X, and this is the maximum height. So here we go. We are going to have, let's start fresh, S equals negative 16t squared plus 160t. We use our quick and dirty little formula for H, which is negative b over 2a. So this is going to be negative 160 over 2 times negative 16, which is going to be negative 160 over negative 32. Negative over negative is positive. Thank goodness, what would negative time be? And I get my trusty calculator and clear it. Stop. 160 divided by 32. 5. Takes 5 seconds. Because this is in feet per second. So 5 seconds is how long it takes.
Miss Barbara, when we're dealing with H or time, should we always know it's negative b? Or is that a formula we should have memorized?
Oh yes, oh yes, oh yes, oh yes, oh yes.
Okay.
It's short, so it's not going to hurt real badly.
Okay. Just making sure.
Good. Thank you for asking. It takes the ball 5 seconds to reach its maximum height. Now, what is that height? This is why even if, like in this problem, they didn't ask about the time. They only ask for the height. But you've got to find the time before you find the height. This is how you find the height. You take the 5 seconds and you put it in for t. And that'll be what k equals. Okay, so I'm going to get out my trusty calculator and say -16 parentheses. I don't have to say parentheses. It's a positive number. So I'm going to go back and say times instead. -16 times 5 squared plus 160 times 5. Enter. 400 feet. Our ball is going to get as high as 400 feet and no higher. So, 400 feet is the answer. So how to do this? In these, you're always going to be given the formula after a lot of verbiage explaining what the formula is. Yeah, there it is. So remember, you have to find h before you can find the maximum height. You find the h, and then you insert it into t in order to find the maximum height. Because it's the height after 5 seconds. That's what the maximum is. And if you want to call it a point, it's located at 5,400. Now we've got a toy rocket. Again, oh dear, this is not letting me save. Okay, whatever. A toy rocket is shot vertically into the air from a launching pad 6 feet above the ground, with an initial velocity of 144 feet per second. Good. Now we know that V sub 0 or V naught is 144 and H naught or H sub 0 is 6. And they give you the formula after they tell you all this. They make you read all this. They make you nervous about it. The height in feet of the rocket above the ground at t seconds after launch is given by this function right here. H of t, h is a function of time, equals -16t squared plus 144t plus 6. Let's write that down. Okay, now let's see what they're asking. how long, that's time, right? How long? How long will it take the rocket to reach its maximum height? And what is the maximum height? That is the vertex, the whole vertex. That's what it represents. That's what it is in this problem. You've got this toy rocket. It's 6 feet above the ground. When it goes kaboom, its maximum height is going to be here at what we call HK. The H is different. It's not the same as that H. HK. H represents the time, really, that it takes to get up to K, and they're asking for both this time. So we're going to use the other H equals negative B over 2A. Let me write different H. Okay, it'd be nice if everything had a different letter. Okay, now H equals negative B over 2A, so that'll be negative 144 over 2 times negative 16. So that'll be negative 144 over negative 32. And that will be, well, we could just leave the negatives. Doesn't hurt anything. 144 divided by negative 32. And that's 4.5. It's going to take 4.5 seconds. 4.5 seconds to reach its maximum height. And its maximum height will be H, the height at 4.5, which is going to be negative 16 times 4.5 squared plus 144 times 4.5 plus 6. Okay, negative 16, and I want to use parentheses just because I'm used to it. Negative 16 times 4.5 squared plus 144 parentheses 4.5 plus 6. Enter. 330. This is going to be 330 feet above the ground. After 4.5 seconds. Okay, see, this is real fast. This takes almost no time at all. Discussion or questions? Now this is a completely different topic. Not mathematically, but this is finance. For those of you who are business majors, you'll learn from this. The profit of a company in dollars is the difference between the company's revenue and cost. The revenue is the amount of money you take in. The cost is the amount of money that goes out. Your profit equals revenue minus cost. Always. What's more, cost is always broken down into at least two parts and often into more parts, whatever the accountant of the company needs. It's not unusual, though, for revenue to just be one thing, but here it's two. Different accounts, like they have it in WAC. There's a different account for scratching your nose, you would think. Well, so we are going to take the revenue, 840x minus x squared, and subtract the cost, 2,500 plus 60x. So let's come down here and calculate that. Determine the maximum profit of the company. Well, first, we've got to figure out what the profit is. We don't know what the profit is. We've got to calculate it from revenue minus cost. So 840x minus x squared minus parentheses 2,500 minus 60x. Well, let's see, 840x minus x squared minus 2,500. And now one of the main mistakes on the test was forgetting to distribute the minus sign to the other number, plus 60x. All right, well, let's rearrange this so we have our like terms together. Negative x squared plus 840x plus 60x minus 2,400. 2,500. Equals 0. Negative x squared plus 900x minus 2,500 equals 0. So now we have our quadratic. Let me double check. Yes, so that'll be minus to both of them. Now, I don't know why I'm putting that 0, it's just habit. You see what habit can do to you? Because they're not asking about that. They're saying determine the maximum profit. Well, the thing is that B is determine the number of items that must be produced and sold to obtain the maximum profit. And you have to know that answer first. That's what your H is. This is K. Okay, the cost, C of X, blah, blah, blah. Here, this last sentence tells you. The X represents the number of items produced and sold to distributors. Or I guess it should be produced and sold to distributors. Yes. So, we don't need to calculate anything. We don't need to say equals to anything. We're just going to find H and K, but I have to find H first. So H equals negative B over 2A. Now here's B. Negative 900 over 2 times negative 1. So that's going to be negative 900 over negative 2, which will be positive 450. Now let's see if that's in thousands or millions or... Nope, it's just straight up. You need to produce 450 thingies in order to reap a maximum profit. Let's find out what that is. So K is your max profit. Negative 450 squared plus 900 times 450 minus 2,500. Yes, I can't hear.
In the equation of H equals negative B over 2A. So I understand the 900 and then the 2 times the negative 1. So we're just dropping the x's, right? We don't need that in this equation.
We're dealing with pure numbers, yes.
Just pure numbers. Okay.
For H. For H,
will
yes.
that always be that way when you're dealing with H?
Yes.
Yeah. Okay.
But for K, you take the H number and put it in for the X's, or the T's, or whatever your variable is.
Okay.
Okay, good question. They're all good questions. All right, I'm going to pull up the calculator and clear it. And now, negative parentheses 450, parentheses close squared, plus 900, parentheses 450, minus 2,500? Yeah. Minus 2,500. $200,000. Woo! You are going to get a profit of $200,000. Now, for me, that'd be more than enough. But maybe for some big companies it wouldn't be, but for small companies it would be. So that's your maximum profit. Your maximum profit is going to be $200,000 if you manufacture and sell or produce and sell 450 of whatever it is you produce and sell. Again, we're doing it this way because we have a quadratic. And then this is the last one of these. Notice, yeah, and these are all of the problems. I think that's pretty good. Okay.
Miss Barbara?
Yes, yes, yes.
I'm sorry.
No, don't be sorry.
What I don't understand is the negative 900 over the 2 times negative 1. Where did the negative 1 come from?
Okay, H equals negative B over 2A. And our A is negative 1 in this case. Yeah, B is 900.
Yes.
And A is negative 1. The number in front of the x squared is what A is.
I'm still not getting it. I'm sorry. One more time.
A is the number in front of the x squared.
Right.
And that's negative 1. That's where the negative 1 comes from.
Oh, okay. I'm sorry. Okay, got it. Got it.
Terrific.
Okay.
Good. More questions. This is a good time.
Okay. Yep.
More. Okay. Wonder if it'll let me save. Damn. What is going on here? I don't know. Okay. A rancher needs to enclose. You've got a nice picture over here, okay? And I'll even put some blue water running in the river. This rancher, I don't know, he's not bright. He's decided that his cattle are not going to cross the river. Don't cattle get in water? Anyway, okay, all right. Far be it from me to argue with him. See, I'm going to do this because let's face it, he thinks his sheep and his cattle are not going to go in the water. So what his idea is, if you read this, is he's going to have 2 corrals, one for the sheep and one for the goats. No, that's the Bible. One for the sheep and one for the cattle. Oh, we should have goats there. That would be fun. Okay. So, and he thinks that he doesn't need to put up a fence here because the river will form enough of a barrier for the cattle. Okay. Now, if the river forms one side of the corrals and 270 yards of fencing is available, find the largest total area that can be enclosed. Okay, this is what we're going to be using that 270 yards for. For this side, plus this side, plus this side, plus this side. and he wants to maximize his area. Area is length times width. Okay, meanwhile, our 270 yards of fencing is going to go for W plus W plus W plus L. So that will be 270 equals 3W plus L. Okay. So we need to get length times width. Okay, we don't have any kind of formula for length times width. We're going to use this to solve either for W or for L. And if I solve for W, I'm going to be dividing by 3. I would have, let's see, I would subtract L from both sides. So I would have 270 minus L over 3 equals W, and I would have a fraction. And I really don't want a fraction, but notice that if I were to solve for L instead, go back here, 270 equals 3W plus L. Three W minus 3W is 0. We'll have L equals 270 minus 3W, which is not a fraction, which is a good reason to use that. So I will change this to area equals 270 minus 3W times, well, I don't need that, times W. Doesn't hurt though. Okay. So let's go ahead and multiply this W in 270W minus 3W squared. That means area is going to equal negative 3W squared plus 270W. That's a formula for my area. You're going in and out.
Extra W. I understand the 3W, but where did the other one come from?
Over here. Oh, I understand. Yeah, area equals length times width. And
okay.
yeah. So it's just a matter that if I solve for L over here, then I'll get 270 minus 3W. So L is 270 minus 3W. Meanwhile, it's times W.
Oh, okay. I see it now.
Okay, great. Okay, now, there's still not a whole lot I can do with this because I don't know what the area is. I know what the length of the sides are. However, they're not asking us that. They just want the largest total area. Well then, all I have to do is find H. In this case, H What would H be? H would be A. Yeah, HK in this case, H is always the X coordinate, and it's W this time that's acting like an X. It's acting like an X. We could just as easily put X squared in there, an X here. So the W is going to be the H. And so we're going to find the H and then we're going to find the K. So we're going to find the W that will cause the area to be a maximum, the very largest it could be. So let's do this. Our A is -3 and our B is 270. So H is going to equal negative B over 2A equals negative 270 over 2 times -3 equals, oh, I don't like this, negative 270 over -6. Which is, all right, it's going to be a fraction, isn't it? Probably. Depressing. No! Well, goodness, this is a good day. 45. H is what the width needs to be. 45 and 45 and 45. In order for the length to be what it would normally be, I mean, given that that's 45 plus 45 plus 45, that's 3 times 45, which is what? 165? I don't know, I'm not going to guess. But 45 is what the width needs to be in order to maximize the area. So let us, there are actually a couple of ways to do this now. But let's do it the way we're supposed to do it. And that is that the area will be a maximum if the width is 45. Okay, so again, use our friendly calculator and take -3 parentheses 45 parentheses close squared plus 270 times 45. I should have used parentheses, but oh well. 6075. You will get the maximum area, the biggest bang for your buck, if you prefer, by making each of these 45, 45, 45, and then let's see what L has to be. 3 times 45. That's 15. 135. Okay, now what do we have? We have 270. 270 minus 135 is 135. So L is going to have to be 135. I mean, it will be forced to be 135 simply because we're using 45 plus 45 plus 45 on those 3 widths. Now what that means is instead of finding that as the area, we could have found the length and then multiplied 135 times 45 and gotten the same answer. 135 times 45, and that also is 6075. When it comes to these kinds of problems, you kind of have a choice about how to find your maximum area. Because if you decide the width is going to be something, the length is automatically forced to be something, and the other way around. But anyway, here's our answer. And this is in yards. So 6,075 squared yards, or square yards. In normal, everyday real estate, I guess, they'd probably do it in acres, wouldn't they? But anyway, if they were going to do it in yards, they would write it like this. Square yards and yards squared are the same thing. It's just the way math people write it. Every culture has its own way of writing. Okay, here is this problem. Complete with blue water. Thank you. Any more discussion about this? Woo, that's it for this.